Section 3. How do plate tectonics and global ocean currents affect climate? Digging deeper. Changing continents, ocean currents, and climate. How ocean currents affect regional climates. In the Investigate, you used models to explore the factors that affect the flow of ocean currents in 3 geologic periods. You also analyzed and interpreted data on maps to understand how patterns of surface currents affect climate. This digging deeper will help you to understand more about those factors and learn about deep ocean circulation. A community near an ocean has a more moderate climate than one at the same latitude inland. This is because water has a much higher heat capacity than rocks and soil. Oceans warm up and cool down more slowly than the land. Currents are also an important factor in coastal climate. A community near a cold ocean current has cooler weather than one near a warm ocean current. For example, Los Angeles is located on the Pacific coast near the cold California current. The city has an average daily high temperature in July of 75 degrees. Charleston, South Carolina is located at a similar latitude. However, it is on the Atlantic coast near the warm Gulf Stream. Charleston's average daily high temperature in July is 90 degrees Fahrenheit. How ocean currents affect global climate. Patterns of ocean circulation also have a strong effect on global climate. The equator receives more solar radiation than the poles. However, the equator is not getting warmer and the poles are not getting colder. That is because oceans and winds transfer heat from low latitudes to high latitudes. One of the main ways that the ocean transfers this heat is by the flow of North Atlantic deep water, NADW. It works in the following way. In the northern North Atlantic, the ocean water is cold and salty. This is because little fresh water is added to Arctic oceans by rivers and precipitation. It sinks because of its greater density. It flows southward at a deep level in the ocean below warmer layers. Then, at low latitudes near the equator, it rises up toward the surface as it is forced above the even denser Antarctic bottom water. Water from low latitudes flows north at the ocean surface to replace the sinking water. As it moves north, it loses heat. This slow circulation is like a conveyor belt for transferring heat. This kind of circulation is usually called thermohaline circulation. Thermo stands for temperature and haline stands for saltiness. When this conveyor belt is disturbed, the entire global climate is affected. For example, about 12,000 years ago, Earth was coming out of a glacial age. Glaciers were melting rapidly. The melting glaciers discharged a lot of fresh water into the North Atlantic in a short time. The fresh water decreased and the salinity of the fresh water decreased the salinity of the ocean water. This reduced its density and slowed down the turning over of the ocean where the warmer waters replaced colder waters as they sank. The decrease was so great that the production of NADW slowed down in a few hundred years. This seems to have plunged the world back into a short, cold period. This period lasted about 1,000 years. How plate tectonics affect global climate. The positions of the continents on Earth change as Earth's lithospheric plates move. The arrangement of the continents has a strong effect on Earth's climate. Think about the requirements for the development of large continental ice sheets. Glaciers form only on land, not on the ocean. For an ice sheet to develop, there has to be large land areas at high latitudes where snow can accumulate to form thick masses of ice. Where oceans occupy polar areas, accumulation of snow is limited by melting in the salty ocean waters. Polar oceans, such as the Arctic Sea around the North Pole, are mostly covered by pack ice. This ice is no more than several meters thick. Today, there are two continental landmasses with permanent ice sheets. They are Antarctica in the southern hemisphere and Greenland in the northern hemisphere. The continent of Antarctica has not always been centered on the South Pole. About 200 million years ago, all of Earth's continents were welded together. They formed a single continent. This was the supercontinent called Pangaea. Pangaea was eventually rifted apart into several large pieces. One of the pieces moved slowly southward. This is the present Antarctica. Eventually, it moved close enough to the South Pole. Ice sheets formed. In recent geologic time, Antarctica has been directly over the South Pole. Therefore, the Antarctic ice sheet has remained in existence even during interglacial periods. Scientists know this because otherwise global sea level would have been much higher during the interglacial periods of the past million years. In the Investigate, you used a model to examine the Antarctic Circumpolar Current, or ACC. Antarctic Circumpolar Current, ACC. This ocean current flows eastward or clockwise around Antarctica. It is the most important current in the Southern Ocean. It is also known as the West Wind Drift. The ACC reaches depths between 2,000 and 4,000 meters and a width of up to 2,000 kilometers. This huge area produces one of the largest ocean currents by volume on Earth. The current is driven by strong winds between 40 degrees south and 60 degrees south. The winds average about 30 to 40 kilometers per hour, or 17 to 23 miles per hour. The average ACC temperature ranges from -1 to 5 degrees Celsius. Depending on the time of year and location, northerly flows feed cold water into the Atlantic, Indian, and Pacific Oceans. They redistribute heat to influence patterns of temperature and rainfall. The waters of the ACC freeze during the winter and warm during summer. This strongly affects the renewal of deep ocean water. Many scientists infer that the ACC caused or stabilized a full glaciation of the Antarctic region. This would have occurred about 33 to 34 million years ago. The last two barriers to the flow were south of Tasmania and south of South America. Scientists continue to study marine and tectonic evidence. They do so to try to determine the exact timing of the opening of the deep gap that controls the flow and affects climate. Presently, most of Earth's continental land area is in the northern hemisphere. Much of North America and Eurasia is at a high latitude. Ice sheets form during times with decreased global temperatures. During times of increased global temperatures, ice sheets melt away. The North American and Eurasian ice sheets have melted away completely during these parts of the cycle. It is very different in the southern hemisphere. Except for Antarctica, there is not a large amount of continental land area at high latitudes. Therefore, large continental glaciers do not form. Plate tectonics, volcanism, and climate. Plate tectonics affects climate in other ways besides changing the positions of the continents and ocean basins. Volcanoes form along active plate margins. Greater amounts of tectonic activity at these margins causes increased volcanic activity. Volcanoes release carbon dioxide. Carbon dioxide is a gas that traps heat in the atmosphere. You will learn more about carbon dioxide in the following section. In this way, plate tectonics might cause global climate to warm. However, volcanic eruptions also add dust to the atmosphere. Dust blocks out some solar radiation. This tends to decrease global temperatures. For example, ash that erupted from Mount Pinatubo in the Philippines in 1991 affected global climate. Geoscientists have found evidence that volcanism in India may have played a role in the extinction of the dinosaurs 65 million years ago. The Deccan Traps are basaltic rocks that formed from lava flows that lasted several 100,000 years. This event would have released large quantities of carbon dioxide from the mantle into the atmosphere. Most scientists believe that the impact of an asteroid is the main cause for the dinosaurs becoming extinct. Following the impact, dust blocked out the sun and 3/4 of life on Earth perished. However, the carbon dioxide from the Deccan Traps would also have contributed to creating a harsh, toxic environment. The oceans would have become more acidic and plankton would have died off, killing a major part of the food chain. Despite Earth experiencing a 2 degree centigrade drop in temperature due to dust in the atmosphere, it could have been worse. Carbon dioxide from the volcanism acted as a greenhouse gas and kept the atmosphere from cooling even further. You will learn more about greenhouse gases in the next section. Tectonics, uplift, and climate. Continent-to-continent collisions create huge mountain ranges. The Himalayas and the Alps are modern examples. Adjacent to each mountain range is a broad and flat elevated area called a plateau. Plateaus rise into the cooler upper levels of the atmosphere. In winter, they are usually covered by snow. Snow reflects incoming radiation back into space, causing even cooler temperatures. Large mountain ranges, such as the Himalayas and the Alps, also obstruct the flow of high-level winds in the stratosphere. This causes changes to the basic circulation of the atmosphere. As a result, moist or cool air can be diverted to feed into glacial systems. Additionally, the wearing down of such mountain ranges by chemical reactions uses up carbon dioxide from Earth's atmosphere. This means that there is less carbon dioxide in the atmosphere. The result is a cooler global climate. The Appalachians were much taller and more rugged when they first formed. They were part of a much larger mountain belt containing many mountain ranges. Some parts may have been as tall as the Himalayas. The mountains have undergone 300 million years of erosion. This has given them their lower and well-rounded appearance. On a global scale, all that weathering may have contributed to the period of glaciation. Scientists think that this period began about 300 million years ago and ended about 280 million years ago.